Have a look at the summary of all the chemical reactions that we have learned in this chapter. In this chapter, we started with alkane. And the general formula is CnH2n plus 2. One of the example is ethane. And the displayed formula is like this. It's fully saturated. So this alkane can be cracked down to an alkene. From an alkane to an alkene, the reaction is called cracking. 裂化反应. After cracking, this alkane could be cracked down to an ethene and a hydrogen. But there are other examples we have seen. And after cracking, it becomes an alkene. How can it becomes an ethane backwards? We can use addition reaction. We need to add 2 hydrogen atoms on, so the addition reaction would involve a hydrogen molecule. This is called hydrogenation. And the reaction condition is heat and a catalyst. The catalyst is a nickel. Hydrogen is not the only thing that can be added on. We can add others as well. Let's look at some other addition reaction of alkene. I'm gonna make a box over here. So for alkene, we have looked at the hydrogenation or the addition of hydrogen molecule. Let's add a bromine molecule over the carbon-carbon double bond. Adding a bromine is called bromination. Adds a bromine molecule, and this happens at the room temperature. It has a color change. So the color change is the bromine water will be decolorized. From the original color of orange to colorless. So the addition product will be, you keep the original C, H, 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 H. You keep the 4 hydrogens and you add on the bromine atoms from the bromine water. And this is a test for the presence of a carbon-carbon double bond. In addition to bromine, we can add the water molecule over the carbon-carbon double bond as well. And this is called a hydration reaction. That involves adding an H2O, steam. This reaction involves high temperature, pressure, and a catalyst of phosphoric acid. Again, you can keep the 2 carbon and the 4 hydrogen atoms and add on the water molecule. You can split up the water molecule into a hydrogen and an OH group, and this will become an alcohol. And this alcohol is C2H5OH, ethanol. The most common alcohol, because we have formed a new functional group. I'm going to draw a box around it. And let's have a look at some alcohol reactions. How to produce alcohol? We can produce alcohol from fermentation or the hydration of ethene. This is the chemical way of producing an alcohol, and the biological way is fermentation. From glucose to an alcohol, this is the anaerobic respiration. Of yeast. It's not the anaerobic respiration of human beings, because after anaerobic respiration we don't produce ethanol, we produce lactic acid instead. And the chemical reaction is C6H12O6 going to 2 molecules of C2H5OH and 2 molecules of carbon dioxide. This reaction is exothermic because it's respiration, it always releases heat. And it always involves a living organism, yeast. Because heat is released, this reaction would follow an increased reaction rate at the beginning, if you plot the rate of reaction against time, you'll see an interesting change. At the beginning, the reaction rate increases, but then the reaction rate decreases. The reason for the increase is because of the increase in heat. An increase of temperature. And it increases the rate of reaction, and also it increases rate of yeast reproduction. You get more yeast as time progresses. Sorry, I forgot to plot the y-axis as time. However, after a certain period of time, you accumulate more and more ethanol, which is toxic to the yeast. So, as time progresses, yeast dies. Not only that, you start to use up your starting material, glucose. Glucose used up. The last reaction that we look at is the reaction involves carboxylic acid. How can we get ethanol to carboxylic acid? It involves oxidation. You can either use the natural way, fermentation, and that involves bacteria, or the chemical way, which is using an oxidizing agent. The common oxidizing agent that we use is acidified potassium manganate. And the product will be an carboxylic acid. CH3COOH. Carboxylic acid. The name is called ethanoic acid. Carboxylic acid always ends with oic acid. And that's the last functional group. we see. Okay, I'm gonna put a box around the alkane as well. Okay, and lastly, we have looked at the reaction between ethanoic acid and alcohol, between the carboxylic acid and alcohol. When we put these two together under the condition of concentrated sulfuric acid, it produces an ester. And we can split up the ester into two components. One component comes from the carboxylic acid, and the other component comes from the alcohol. The part that comes from the alcohol is the alkyl part. It ends with YL because it has two carbon atoms. It's an ethyl group. And the other part comes from the carboxylic acid, and that's the group ending with O8. And that's ethanoate. And this is an ester. Okay, that's the last functional group. Oops. That's all the summary of the reaction that we have seen in this chapter.